Hi guys, and welcome to the general form of any rational equation. So we've looked at, if you've watched the other videos, we've looked at two examples of equations that are rational equations. And in both of those examples, the only variable that we have is an x. Okay, there's no exponent for it, there's no x squared, no x to the 10th power, just a regular x. But rational equations don't have to have just a regular x. Rational equations just have to be one polynomial above another. Okay? And so we want to look now at the rational equations where there are actually exponents involved. It's really much more difficult to write down this kind of general equation, and so you end up with something very scary looking like what you have right here. And I'm sure a lot of you see something like this and you look at it and you go, oh my god, no way, I am shutting down, there's no way I'm even looking at this. But I don't want you to be scared by all of the numbers and the numbers in different places and the letters and all of that in here. Don't be frightened by it. Just, we're going to break it down just a little bit. Just go over exactly what is it that this is saying. So all this is really saying is that some rational function, like that's what this f of x stands for, equals some polynomial, so p of x we'll call it, over another polynomial, q of x. Okay, and that's just showing us that these are all going to have x's in them. Okay, and then it expands it to say that basically what we have is all of these a's, which just stand for different coefficients, okay, times on the top a bunch of x's to different powers. So we could start with x to the 6th power, and then the next term would be x to the 5th, and down so on and so on until you get just to x and then just your constant number. Okay, and then the bottom says exactly the same thing. So there could be a bunch of coefficients here, whatever, and then you have x again to some power, say the 3rd power, then you'd have x squared and then down to just x and then just your constant number. Okay, so that's really all it's saying, is that you just have some polynomial over another polynomial. So the most important thing that we want to take from this is what those largest exponents are. Okay, that the top we're going to call that m, and on the bottom we're going to call the largest exponent n. And this is really important because if you look down here at these rules that are going to help us, it's going to help us determine which one of these to follow. Okay, so if m is smaller than n, we're going to do one thing. If they're equal, we're going to do another. If m is larger than n, we're going to do one more thing as well. Okay, so that's the most important part of what you see here. So just a quick going over of the kinds of things that you can tell from this kind of equation. So the x-intercepts are always where the numerator equals 0. So if you just look at the numerator, just look at the top of your equation and set it equal to 0, that will give you all of the x-intercepts of the graph. Okay. Another thing we can tell is the vertical asymptote. Now, the ones we have looked at before only have one, but your graph might have more than one vertical asymptote depending on what the graph is. And so those are where the denominator equals 0. And sometimes we'll find that it wouldn't be possible for the denominator to equal 0, but the vertical asymptotes are wherever that is, if there is a possibility, if there's a way for that to happen. Okay? And then this is our conditional thing. This is what I was saying about m and n being important to tell the difference between them. So if your largest exponent on the top is smaller than the one on the bottom, then y equals 0, which is the x-axis, is the horizontal asymptote. If they're equal, if the exponents are equal, then y equals am over bn, and all that is, remember you're just looking over here, all it is it's the leading coefficient of the top one over the leading coefficient of the bottom one, and that's all. And then if m is greater than n, then the graph has no horizontal asymptotes. It also has the n behavior of am over bn times x to the m minus n, but we're not going to be looking at graphs like that, so I didn't want to spend too much time there. So just these are some examples of the kinds of things that you'll see, which look much more friendly than this crazy thing up here, but these are just examples of the kind of equation that is talking about.